share my screen. So hello and welcome to the SLMCS geometry course. I'm going to go over a few things today. So today's schedule is going to be me introducing myself, the instructor. I'm going to introduce the course, what you need to know for the course, like the course textbook, the materials, everything you need to know. I'm going to go over the course syllabus, so what we'll be learning over the next 15 weeks. And at the very end, once I'm all done, we will have an open Q&A session where you can ask me anything about myself or the course. Let's get started. So hi, I'm Alex Chen. Some key things about me. I was part of the Missouri Math Counts national team from 2018 to 2019. I'm a two-time Amy qualificant, a two-time Excellence in Math winner, and outside of math, I am an avid pianist, rocketeer, and tennis enthusiast. Here's a picture of me representing the Missouri Math Counts team over in Orlando, Florida, alongside my 3 teammates. So let's talk a little bit about the course. This course is formatted like mathematics takes place in the real world. So what that means is that it's very interactive and there's a huge engagement element. So we will have interactive lectures on Sunday from 4:30 p.m. to 5:20 p.m. And in these lectures, I'm learning alongside you. You can ask me questions and it's very interactive and students will have a lot of opportunities to jump in and learn alongside me. I will have office hours from Wednesday, 8 p.m. to 8:45 p.m. This is really a chance to catch up, ask me any questions, get caught up on homework. If you missed a class, you can come in then and I can get you caught up. It's really, I'm making myself available for you and you can basically ask me anything at that time. I will also be sending out individualized course progress reports for each and every student that enrolls in this course 2 times throughout the 15 weeks, once halfway through and once at the end. And these course progress reports will report on everything from attendance, how the kid is doing on homework, and I will give detailed tips on how to maybe improve in your geometry skills. This course is very comprehensive. First off, it's self-contained, which means you don't need to bring any prerequisite geometry knowledge. I do require a little bit of arithmetic and some basic algebra skills because that will make understanding some of our theorems easier, but you do not need to come into this course knowing anything about geometry. And the course will build on itself, so everything that we learn will be based on something we've already learned before. We're going to cover key concepts seen in major math competitions, such as AMC and math counts. And we will strive to go above and beyond a common core geometry class that you would see in your K-12 school. At the end of this course, students will be prepared for almost all AMC 8 geometry and most of AMC 10 and 12 geometry questions. This course does have a mandatory textbook, which is Introduction to Geometry by Richard Rustick. This course starts on January the 9th, so I'd highly recommend you pick one of these up as soon as possible. I will put a link to purchase this in the chat right now. So I have just pasted the link into the chat. I think it's $55 for just the textbook itself, and I recommend you buy the solutions, which will be $60. You can also buy a secondhand one off of Amazon. I don't know exactly what the price range is for that, but I suspect it's probably around $40 used condition. This course does have a little bit of homework. I don't expect this to take long. Every week, maybe 45 minutes to an hour, depending on how familiar you are with the content. This homework consists of weekly reading previews. This reading preview, I just ask you to skim the chapter we'll be covering in the next lecture. That way you don't come to class with a good understanding and you come prepared with questions that you like to ask about the reading. And you're not completely lost when I start covering new concepts. The homework also has an original problem set written by me. and I will grade that problem set with individualized feedback. Um, and I will post and submit these, and students will submit these through a Google Classroom, which I'll send out once everyone is enrolled. The goals of this course are to provide a solid foundational understanding of geometric principles, theories, and proofs to students. We strive to master and be fluent in key geometric principles and have a good understanding of how geometrical principles can be used to solve abstract and real-world problems. These three concepts are combined in something called the mathematical trinity, which is a skill that I like to teach. So the mathematical trinity consists of three main ideas. Number one, concepts. Number two, applications. And number three, fluency. So concepts, I teach you what do these ideas mean. In applications, why do these ideas work? And fluency, how do I use these ideas to solve problems? When all three of these points are mastered, we can truly say we've mastered the art of geometry, or any mathematical concept in that case. This course does have a little bit of prerequisites. I need you to have a good understanding of arithmetic, fractions, and basic algebraic concepts. As I've already said before, no prerequisite geometry knowledge is needed. But one of the main questions that I do get when people are signing up for this course is my child ready? So I prepared a quick diagnostic test to see whether you're ready or not. So on the next slide, I have 3 questions, and on the next slide, there will be 3 more. I recommend that you write your answers down to these 3 questions, these 6 questions actually, on a separate sheet of paper so you can check them later. And I will give you 3 minutes for this set and then 4 minutes on the next set because it's a little bit harder. So if your children are there or your students are there, I guess your time starts now. I'll give you 3 minutes. Okay, so that has been 3 minutes. So I'm going to move on to the next three questions, and I'll give you 4 minutes to answer these. You may begin. Okay, that has been 4 minutes. So I'm going to move to the answers. I'm going to give you a few seconds to check your work. And if there's any questions over any of these problems, you can ask me how to solve them and I'll go over them with you. So here are the answers. I think most of these are pretty self-explanatory. Maybe number six, you're not used to seeing the syntax. Basically, this um, rounded E looking thing, that's the Greek symbol epsilon. And that means it's an element of a set. And then on the right here, this is a set notation. So this basically means that X can be any of the real numbers from -3 to 7. And these square brackets mean that the numbers -3 and 7 themselves are members of that set. So if I plugged in 7, it would work, and if I plugged in -3, it would also work. If you see rounded braces, it means that that number is not an element of a set. So like if I had a parentheses mark over here, then -3 would not be a member of that set. So if we go back, we can see that 7 minus 2 equals 5. The absolute value of 5 is 5, and that meets the equality case of less than or equal to 5. So that number 7 works. Does anyone have any questions about these, or how is everyone doing? Okay, I think we're going to move on because I don't think anyone has any glaring issues. So here we go. If you got 5 to 6 on that test, I think you're good to go. You're completely ready for this course. If you got 3 to 4, you might need to put in some extra work, but this course is still pretty much suited for you. If you got less than 3, then you might not be ready yet for this course. I would advise you to keep working along your mathematical journey, study some algebra, some arithmetic, and once you're ready, come back, maybe next year, maybe a few years from there, and I'll still be here, hopefully. If you made like a silly mistake, like you maybe you distributed wrong, don't worry. It happens to the best of us. This course is probably still good for you. All right. So now that I've gone over everything you need to know about the course, I'll be covering what will happen next in the next 15 weeks. So in week 1, it's a very introductory course. I will be introducing myself, getting to know the students a little bit, and I will also be introducing terminology, which is basically just the names of things that you need to know in order to succeed in geometry. So basically like what's a point, what's a line, what's an angle, and these types of things, so that we can have a standard base of vocabulary that we can work off of. In week 2, I'll be covering angles, which I call the root of all geometry. I'll be covering angle measurement, straight and vertical angles, parallel lines, the angles in a triangle, and exterior angles in this week. Basically a lot of proofs and basically getting to know the basis of all geometry angles. In week 3, I'll be covering triangle properties and congruence. I call this geometry's favorite shape because almost half of the problems you see in introductory math competitions come down to a triangle. So we'll be covering some basics of the triangle, such as perimeter, area, and congruence theorems. And we will also be covering the proofs of those congruence theorems. So in the case that you forget, which is unlikely, you will still be able to derive them. In week 4, we're going to talk about special triangles. This is your equilateral triangle, your isosceles triangle, and we're going to talk about their properties. In week 5, we're going to talk about triangle similarity. Like triangle congruence, this is also very useful, which is why I call it how to solve 50% of geometry problems. A lot of geometry comes down to similarity and how can I use the traits of one shape to derive the traits of another shape. So I'm going to be talking about specific types of similarity, how to prove that, and how we can use that in contest problems. In week 6, I'm going to talk about right triangles, which is a special type of special triangles. We're going to talk about the most famous theorem in all of geometry, the Pythagorean theorem. We're going to talk about 45-45-90 triangles and 30-60-90 triangles, as well as covering Heron's formula. In week 7, this is where things start to get a little bit out of the comfort zone, we start talking about special parts of a triangle. This is your centroid, your circumcenter, your orthocenter, and your incenter. Um, and what can those points tell us about the triangle itself, and how can we use that to our advantage in contest math? In week 8, I talk about quadrilaterals. Um, Most of quadrilaterals is treating the quadrilateral as two triangles fused together, which is why I call it two triangles became friends. We're going to talk about specific quadrilaterals such as trapezoids, parallelograms, rhombuses, rhombi, rectangles, and squares. And we're going to talk about their properties, how they're similar, how they're different, and what to do when you see one pop up in a question. Polygons, once again, you're treating polygons a lot like more triangles glued together. We're going to talk about how to find the angles of these polygons and also how to find the areas. Circles, in week 10, we're going to talk about the properties of circles, mainly the basic ones such as arcs, circumference, area, and inscribed angles inside a circle. Circles are one of the most beautiful shapes in all of math, and I hope to do them a good justice in week 10. In week 11, we start talking about tangents. This is the week where most of everything starts coming back together. We start to assemble the whole puzzle together. We're going to talk about perpendicular radii, angle formations, tangent equality, and what tangents can tell us about the circle itself. In week 12, we talk about power of a point. I call it circle sidekick because no matter where a point is situated with respect to a circle, you can always derive certain information from it. Whether it's inside the circle, on the circle, or outside the circle, there's always a number called the power of a point, which is the constant through all lines through that point. And we're going to talk about how we can use that to our advantage to learn more about the circle and maybe find some lengths within or outside of it. In week 13, we start to go to analytic geo. This is basically turning a geometry problem into an algebra problem. It's very, the brain power required for analytic geometry is far less than actually solving the problem in a geometric principled way. But so it's essentially a sacrifice of brain power for time. So it's less brain power, but it might take a little bit longer because you have to translate everything into an algebraic problem. But nevertheless, it works. And sometimes when your back is against the wall, this is what you have to use. So I'm going to be talking about coordinate plane geometry, slopes, lines and circles, triangles, and distance between a point and line. These are all the basics that you need to solve any analytic geo problem. And most of the stuff from there just builds up. In week 14, I'm going to introduce you to trig, which is kind of scary for some students. I promise I'll try to keep it pretty simple. I'll be introducing sine, cosine, and tangent, basic right triangle geometry. We're only going to stick to right triangle, sines, cosines, and tangents for now. I might introduce law of sines and law of cosines depending on where we're at, but this is very introductory trig, and it's nothing really to be scared about. And finally, in week 15, which is our last week, I will present a problem potpourri. So these are different problems that I've assembled from all over contests, and some are my original problems, and we'll be solving them together to learn a little bit more about our geometric concepts, to polish up on them, and maybe touch on a few things that we might not have covered in the previous 14 weeks. So that pretty much concludes what I have for you today. I'm going to open this up for question and answer. If you want to ask me a question, you can unmute yourself and I'll try to answer your question to the best of my ability. So Does anyone have questions? I'll open it up. I'm sorry, I didn't quite catch that. Did you ask a question or are we good? Okay, I think we're good. Um, if nobody has any questions, oh,
Hi, Alex.
hi.
Really, thank you. Thank you to introduce this course. It's really helpful, I think. But my son is he's in the seventh grade now. I show him the sixth question you on your slides, but it seems he have a little bit difficult to solve it. So my question is, do you think which grade is better, to take this course?
It really depends on where your student is at
Okay,
regarding their mathematical progression. Uh, I think this course is still it could still suit him. Um,
okay,
if he really wants to take this course, he can try to polish up on some introductory algebra skills. As I've said before, the geometric concepts in this course are self-contained, which means that
yeah,
he doesn't need to have any prerequisite geometry knowledge. And most of the algebra is used in week 13. It's not always
okay,
algebra based, so I think this
okay,
will still be a good fit.
yeah, yeah. I think that he already know, some concept, but not too much. I don't think he got. So probably, yeah, we will let him to try.
Yeah,
Yeah, to see.
we start off really slow, so
Okay,
and we build from there. So if he's a little bit lost after the first few weeks, then
good.
we can talk.
Okay, yeah. All right. Thank you so much.
No problem.
Good.
Does anyone else have a question? Oh, okay. I think the questions have run dry. So
Can I say something?
yes, go ahead.
I'm in fourth grade, and I just looked at the prompts, and I was kind of struggling with some of them. I was able to get like maybe two or three right. And I'm asking like, do you think I'm able to like uh do this like class?
Yeah, as I've said, a lot of the geometry actually in this course starts from the ground up. So I don't think you need to bring any prerequisite geometry knowledge. A lot of the algebra that you saw is used in just one specific segment of the course. Having a strong foundation in algebra would really help, but you don't necessarily need it so much to completely succeed in this course. So to answer your question, um, we can take a few lessons. If it doesn't work out, talk to me and I'll find a plan for you.
Okay, thanks.
No problem. Anyone else?
Um, how much homework is there?
Okay, I it really depends on the week. For the first few weeks, we start very slow. Some of the first few lessons, you're going to be very familiar with the topic because you've probably learned it in school already. So I expect it to be no more than 30 minutes for the first few lessons. But as we go to the as we progress to the later lessons, it's going to be very critical that you read ahead and you have a brief understanding of the topic before you come to class. So I expect the later we go, that number will increase. I will try to keep it so that all of your homework is within an hour or an hour and a half at most. Um, but it really depends, and it also depends on like where you are in your mathematical journey. So like if you're super good at algebra and you know a lot of these geometric concepts, it's clearly going to be a little bit shorter time frame for you. But overall, I think 1 hour a week. So if you spread that across 7 days, it's 10 minutes of reading a day. It's shouldn't be too much for you as long as you don't procrastinate. Don't do that.
Also, are there any textbooks?
Yes. The main textbook for this course is Introduction to Geometry by Richard Rustick. I forgot to show a little picture of this earlier, so if I can get it in the frame. This is Introduction to Geometry. This is the prime textbook that's used by competing mathematicians all over the United States. We'll be learning from this. You can pick one up off of the link that I sent in chat earlier, which I'll send again now in case you missed it. Or you can try to pick one up off of Amazon in a used condition. I recommend that you also buy the solution manual. So together they usually come in a package of around $60. So I will put the link to that in chat right now. All right. Any other questions?
I think Mia's gonna need extra attention because she didn't know what to do with like any of those questions.
Yes, I did.
It's okay. I'm here to help you all out.
等人家讲完了你再问。
I'm here to help you all out. I'm your friend, so if you ever have any trouble, come to me. I'll help you out with it. And as I've said before, I try to give every student individual attention throughout this course. A lot of the feedback is individualized. So every child learns at their own pace, and I'm a believer in that. So I'm not going to punish you if you don't know anything, and I can't punish you in any meaningful way anyways. So I'm here to help you improve. I'm not here to make you perfect because no one can do that. So we're all on this journey together. So if you ever need help, come talk to me and I'll find something for you.
So I'm in first grade and I hadn't learned algebra yet, or pre-algebra. I had a hard time learning that. And can I like keep on with this class?
Yeah, you can. As I've said, a lot of the algebra only comes into play near the end of the course, and if needed, I could make one of those office hours that I talked about specifically dedicated to catching you up on algebra skills. So if you don't know too much algebra, I think I will make one of those office hours specifically dedicated to kids who need to catch up on algebra a little bit, so we can get you ready for week 13. But I really think since this course is very comprehensive, then you will be ready. No matter where you are in the rest of your mathematical journey, I will do my best to teach you geometry. And if at some point you realize it's not working out as planned, come talk to me during office hours or at some other time, and we'll work something out.
If the class is full, can I still register?
Yeah, so I just got the notification this morning that the class is full. Um, I don't actually know the policy for this quite yet, so I'm going to need to talk with the principals and authorities about that. So I will try to get an answer back to you as soon as possible about that. And I'm definitely considering opening a second course, but I believe that quality always comes first before quantity. So I've made my promise to give the best that I can to these 16 students who signed up, and if I'm able to, I will definitely strive to open a second course, or we can work something out with the school specifically for you.
Okay, thank you.
Also, if you're on the waiting list, could you please send me your email so I can get an answer to you as soon as possible? Okay, any final questions or thoughts, comments, concerns? Okay, so for those who are a little bit concerned about the algebra part, I would encourage you to just try a couple lessons. If it doesn't work out, we will talk and we'll find a way to work that out. But I think that everyone here, I think the questions are basically done. And if you have nothing else, I think I'll let you go. So I will also, if you need my email information, I will drop that in the chat as well. In case you have any extra questions, I will link that into the chat. So thank you for coming. Bye. Okay.